Today we are talking about the fourth lesson in the proportional unit, and the homework that goes along with this is pages 9 through 12. All right. Some super important facts that we're going to talk about right now, we're going to learn about. I'm going to give you a sheet in class that will have this on it. It is something that you need to know. Okay, I'm going to read this. It says, a proportion states that two ratios are equivalent. In a proportional relationship, when one quantity increases, the other quantity also increases. The ratio of the two quantities remains constant. This ratio is called the constant of proportionality, or K. It is also the unit rate. It's the unit rate. Now, we are going to write an equation. Okay? You can use tables, graphs, and equations to determine if relationships are directly proportional. Basically, if they're directly proportional, they have to have a constant rate of change, which is the constant of proportionality. It's the unit rate. The equation that you need to know is this: y equals kx. That is going to be true for every pair of points, x, y. And if it is, then it is proportional. And k is the constant of proportionality. It is the unit rate. So when we are asked if something is proportional, we need to see if every pair of points is related in the same exact way. So let's take a look at example 1. It says a scientist recorded data collected by a rover sent to the planet Mars. The scientist recorded the time it took for the rover to travel 7 different distances. Identify and interpret the constant of proportionality for this situation. So we've got time in seconds, distance in centimeters. For an equation to be proportional, or any set of data to be proportional, K has to be the same for every problem. We know this. Y equals Kx. Couldn't I divide both sides by x, and I will have K equals y over x. So your constant of proportionality is y divided by x, because that's what K is, the constant of proportionality. It is the unit rate. Now, when we have a table, x is always going to be listed first. So, our constant of proportionality would be 10 over 2. Is that the same as 30 over 6? Is that the same as 15 over 3? Is that the same as 45 over 9? Is that the same as 20 over 4? Now, if you divide those, you're going to get 5 for every single one. That's going to be 5, 5, 5, 5, 5. So, K is 5. Now, not only is it 5, but let's figure out what the label is on it. It's 5 centimeters per second. So, when you are looking at this set of data, the unit rate, or constant of proportionality, or rate of change is exactly the same for every ordered pair, and it's 5 centimeters per second, so it is proportional. Okay, it is proportional. All right, the number of bracelets, Y, that Reese can make in X hour is represented by the equation y equals 3/4 x. Create a table of values to represent how many bracelets Reese can make in 1, 2, 3, and 4 hours. Okay, so let's make this table. Here's our hours. Here's our number of bracelets. They're telling us hours are 1, 2, 3, and 4. How many bracelets can she make? Well, I'm going to use this equation. Y equals 3/4 x. So, this is going to be x. This is going to be y. First, second. So, if I substitute 1 in, I'll have y equals 3/4 times 1. That's 3/4. So, she can make 3/4 of a bracelet in 1 hour. If I plug in 2, y equals 3/4 times 2. If I substitute that in, I'm going to get 1 1/2. She can make 1 1/2 bracelets in 2 hours. If I substitute in 3, y equals 3 fourths times 3. I will end up with 2 1/4, and you can use a calculator if you want. 2 1/4 bracelets in 3 hours, and if I substitute in 4, I get 3 bracelets. Now, it says, what is the constant of proportionality? Well, isn't the constant of proportionality right here? Y equals kx. So the constant of proportionality, k, is 3 fourths. And what does it represent? That is the unit rate. She can make 3 fourths of a bracelet in 1 hour. That's your unit rate. Constant rate of change, constant of proportionality. They are all one and the same. This diagram maps x values to y values. Is the relationship proportional? If so, identify the constant of proportionality. Well, we know that k is y over x. That's our constant of proportionality. Let's see. We'll have 3 over 9, 4 over 12, 5 over 15, 6 over 18, and 7 over 21. If you take a look at every single one of those fractions, they all simplify to 1/3, every single one of them. So, is this proportional? Yes, proportional. And the constant of proportionality, k, is 1/3. Same across the board, because k is y divided by x every single time. That's the unit rate, the constant of proportionality, or the rate of change. They are all the same. Example 4. 2 relationships are described below. Determine whether each describes a directly proportional relationship or not. If the relationship is proportional, identify the constant of proportionality. So, I'm going to do 2 charts. Relation A, relation B. A is y equals the sum of x plus 2. Okay, so let's make a table. X, y. I can pick some x values. I'm going to pick 1, 2, 3, 4. If I substitute 1 in for x, 1 plus 2 is 3. Y will be 3. 2 plus 2 is 4. 3 plus 2 is 5. And 4 plus 2 is 6. That's my first table. My second table, y is equal to 2 times x, so 2x. Let's start with 1, 2, 3, 4. I'm picking any values I want for x. 2 times 1 is 2. 2 times 2 is 4. 2 times 3 is 6. 2 times 4 is 8. Now, let's check and see if these are proportional. Well, for them to be proportional, k has to be the same. And remember, k is y over x. So, y over x, 3 over 1, is that the same as 4 over 2? I don't even need to go any further because 3 over 1 is 3, 4 over 2 is 2. This is not proportional. So there's no constant of proportionality because it's not proportional. Over here, let's check k. 2 over 1, is that the same as 4 over 2? Yep. Is that the same as 6 over 3? Yep. Is that the same as 8 over 4? Yes, they will all be 2. So k is 2. That is the constant of proportionality, and yes, it is proportional. Last example. Oh, these are the steps. We already did that. All right. A school dance committee purchased identical party favors for a school dance. 5 students bought different numbers of favors at different times. Each paid the same price per favor. That's really important, same price per favor. We're going to go back to that. Okay, so identify and interpret the constant of proportionality based on the situation. The constant of proportionality is the ratio k equals y over x. You need to know that. So, let's take a look at this. The constant of proportionality, the first one is 5 over 10, which is 1/2. Now, if we check and see, is this the same for every ordered pair? Is 10 over 20, 1/2? Yes, it is. 6 over 12, 1/2? Yes, it is. 8 over 16, 1/2? Yes, it is. 4 over 8, 1/2. So the constant of proportionality is 1/2. If we add that out, it's 0.50, which we're talking about money here. So that's probably better to have it as a decimal. So it's the ratio of x to y is the ratio of cost per item. Look up here on the table. Cost per item. Cost per item. That's the unit rate. That's how much we're paying. So they paid the same price per favor. We could have answered the question right away. Is it proportional? Yes.